All right, guys, welcome back to Life at Home Chemistry Shorts. This is the second video in this three-part series on balancing redox reactions. And so we're going to go ahead in this video, we're going to talk about using the half reaction method to balance reactions in an acidic solution, an aqueous acidic solution. So let's go ahead and jump into this video and get started, and hopefully this will be helpful to you. So let's take a look at the equation that I showed you guys the last time in the last video. And if you did not see that video, I can put a link below. If you do not know how to determine if you have a redox reaction, or if you actually need to use this half reaction method that we're going to go over today, then I can link to that video and you can go ahead and take a look at that. But if you do know that, then we'll go ahead and jump into it right here. And I pasted the reaction in that we had last time. And in this particular case, we're going to be balancing this in an acidic solution. And if you have an acidic solution versus a basic solution, then versus an alkaline solution, then the balancing is going to be just a little bit different. And so we're going to do acidic solution this time, and then next time we're going to do the extra steps for the alkaline solution, and then we'll just go from there. So if we look at this equation, we can tell very clearly we're not going to be able to balance this just by putting coefficients. Number one, I've got a hydrogen here that I don't have in my product side. And I've got a charge imbalance. I've got a -2 here, but then I've got a +3 and a -1. So I've got a net of +2 over here. So I've got a lot going on, and I don't think I certainly won't be able to get this balanced by just popping in coefficients. So we've got to use something called the half reaction method. So I've outlined the steps over here on the left, and we're going to kind of check these off as we go. And if you don't understand these just by reading them, I'm going to explain them. And the first step is to separate the equation into half reactions. And what that means is we're going to take the oxidation and reduction pieces of this reaction. You always have oxidation and reduction going on at the same time. You won't have one without the other, because something's going to be losing an electron while something else is gaining an electron. So the ticket here, or the key here, is to split these out into their separate oxidation and reduction reactions. And we know that the nitrogen, it's the one that is basically being oxidized because it is losing electrons. So we're going to take this piece out. Okay, and I'm not going to write the aqueous every time just to save time. And then, of course, here, the reduction portion is going to be what's happening to the chromium. And I'm going to take it, and I'm going to split it out right here just beside of it. So we've broken that apart into our respective oxidation and reduction reactions. And so now we've done that. So let's go ahead and I can split this so we can keep these divided up into our two reactions. Okay, so the first thing we want to do is we want to balance elements other than hydrogen and oxygen. So in this particular case, I've got one nitrogen. I'm good. Here I've got two chromiums on the reactant side and only one here, so I need to balance that by putting a coefficient here. Okay, so we've got that. Okay, now we want to add water atoms to balance our oxygen. So what that means is in this particular case here, we've got 7 oxygens on our reactant side, but we don't have any on our product side. So I need to put some oxygens over here, and I'm going to do that by putting enough water molecules to basically balance out my 7 oxygens. So I'm going to put 7 waters to give me the 7 oxygens that I need. In this case, I've got 2 oxygens on my reactant side, 3 on my product side. So I'm going to need 1 water over here in order to get that extra oxygen that I need. So we've balanced our oxygens. Now we want to add H+. Remember, we're in an acidic solution. So H3O+, we're going to use these interchangeably, but I'm just going to use H+ for simplicity's sake. And we're in an acidic solution, so we're going to assume we have pretty much all of that we need to work with. And so what I'm going to do is I'm going to use that to balance my hydrogen. Now, if we look at here at our reactant side, I've got 2, 3 hydrogens. I don't have any on the product side. So I'm going to say plus 3H plus. Now, that's going to balance my hydrogens out. And I'm going to look over here, and I actually have 14 hydrogens. I don't have any on this side. So I'm going to have to say, I'm going to have to put 14 hydrogens on this side in order to balance out the hydrogens on this side. All right. So we've taken care of that. Now we want to balance out our charges. And we're going to do that by putting electrons on either side to balance out our charges. I might have to rewrite this to make sure that I get this all balanced out. But if we look at this side, so over here on this side, it's neutral. You know, I've got neutral, neutral, and then on my product side, I've got a minus, but then I've got 3H plus. And so my net charge over here is 2 plus. So what I need to do is I need to put some electrons in there in order to balance it out with this side. So I'm going to go ahead and rewrite this. So I'm going to say H2O plus HNO2. Okay, so now when I add all this up, it also gives me a net 0 charge, which would be the same as my reactant side. Now let's look over here at this one. This one looks exciting over here. So, because we've got 14H plus here, and then we've got a 2 minus. So that's going to give me a net charge of 12 plus. So now let's look here, and I have got 2 of these chromium 3 plus. So I've got a 6 plus. These are neutral. The waters are neutral. And so my net charge is going to be 6 plus. Now, so I've got to put some electrons in there in order to balance this out. And so I'm going to rewrite this one as well. Okay, so a couple of things here I want to point out that should clue you into if you're on the right track or not. One is, if you'll notice, in both cases, my electrons and my hydrogens were on the same side. They were not on the same side, like they're on the product side here, on the reactant side here, but they were on the same side within my half reaction. Another thing to note is that with your half reactions, in one case, the H plus and electrons should be on the product side. In the other case, they should be on the reactant side. So you should have them on opposite sides. If you have them both on, if you have them on the product side in both cases or on the reactant side in both cases, then that means you've probably done something incorrectly. They should be on different sides. So now that I've done this, I've balanced my charge. Okay, now it says balance my electrons in the half reaction by multiplying by integers. So what does that mean? So I need to, if you look on this side, I've got 6 electrons. However, in this reaction, I only have 2 electrons. So what I need to do is I need to balance all that out. And so the way to do that is by multiplying everything over here by 3. And so I'm going to go ahead and I'm going to do that. And that's my last step before adding everything back together. So I'm going to go ahead and write these on top of each other. So what I'm going to do is I'm going to multiply everything here by 3. And so you can see now I've got the same number of electrons. Now, of course, there can be cases when you have to multiply both half reactions. Like, for example, if you've got like a 3 electron and 2 electron, then you can't just simply multiply it by, 1.5 or something. You might have to multiply both in some cases. And we'll do one of those examples in the next video so you can see that and you can understand that a little bit better. So now I've got this half reaction is finished. Now I'm going to take this half reaction, I'm going to put it under it so that we can do this, bringing them back together a little more easily. So now I've got everything, and I'm going to start putting everything back together. So I'm going to add my half reactions together, and I'm going to cancel where possible. Now let's look and see what I mean by cancel is if you've got something on the reactant, let's divide it up by reactant and product sides. If I've got something on my reactant and product side, I can cancel it out. So for example, I've got 6 electrons on the opposite side. So I'm going to cancel those. I've got 3 waters. I've got 7 waters. So let's take out my 3. I can take 3 out of here as well, which means I'll just erase this. And well, let's not erase it so you can see what happened. I'm going to put a 4 here. Okay. Now let's look for other things we can cancel. So I've got 9 hydrogens here and I got 14 here, which means I can get rid of these. And I can get rid of 9 of these. That leaves me 5. And that looks like that's mostly this type of stuff that you're going to wind up canceling out. You're going to cancel out some of your H pluses and some of your waters. And then, of course, your electrons should always completely cancel out if you've done everything correctly. All right, so let's go ahead and add this stuff back together and see what we have. Okay, so now as a final check, let's balance everything out and let's see what we're left with. So first thing that we're going to notice here is we've got 5 plus 3, we have 8 hydrogens. Here we have 4 times 2, we have 8 hydrogens. 2 chromiums, oxygens, we got 7 plus 6 is 13. Here we've got 9 plus 4 is 13. So nitrogens, we have 3 and 3, and that looks like that's got it. So let's look at our charges to make sure we're good there. So here we've got 5 plus and a 2 minus, and that's going to give us a overall net charge of 3 plus, which means we hopefully have 3 plus over here. So we've got 6 plus, 3 minus, and what do you know? We've got a 3 plus over here as well. So it looks like everything is balanced out nicely. We've accounted for our electrons, our charges, all of our elements are balanced out. And so this is the basic last step done. All right, guys, hopefully this was helpful to you. And in our next video, we'll be taking a look at how to do this same thing, but in a basic solution. And there's just a couple of more steps that you need to do if you're in an alkaline solution. And we're going to do that. And we're also going to maybe take a look at a couple of more complex type reactions to balance out, so you can see not just the straightforward simple ones, but some of the ones that may be a little bit more difficult. I look forward to seeing you guys next time. And until then, good luck with your chemistry.